case anybody needs it. So we're talking about temporary tables and doing the temporary tables exercises. Let's jump right in. So our first exercise has us run a first name, last name, and department name query. Okay, we can do that all day long. And take that query and add on a full name column. Okay, so the first thing I'm doing is I'm starting with the query that's going to give me the first step of what I asked for. And that looks great. So if before creating the temporary table, my workflow is to create the query first to make sure that it's what I need. So once I've got that done, I'm going to actually create that temporary table and then double check that my temporary table exists with a select from that temporary table immediately afterwards. Okay, looks like everything's good. Now, to add a column, we use the following statement: alter table, and then we provide the table name. And in this case, I'm adding a column called full name. And in here, I should actually do the varchar is 31. Now, how did I come to that conclusion? Let's do a describe on employees with departments. Now, describe tells us about the data types. So we see that the first name and last name are 14 and 16 characters respectively. But if we're going to make a full name column, there's like a cultural assumption that we have a space between a first name and a last name, right? So SQL doesn't know about these assumptions. We have to account for them. So that's where this 31 is going to come in to play. So it'll cut off anybody's name. Altering the table generates that specific column, and it's null unless we do anything else with it. So what I'm going to do here is update my new temporary table with a set, and the set is going to concatenate first name, space character in quotes, and then last name. And then I'm going to double check my work after running that. It looks like we now have first name, space, last name. There's no truncating. And the exercise says, okay, well, let's drop the first name and the last name. Okay, we drop the first name and last name, and then we double check our work. So this is setting up a scenario of showing that we can create temporary tables, add new columns to them, and fill those columns, or there's an alternative solution. I'm going to nuke that temp table to show you what I mean. If we can, the exercise says, well, drop first name and drop last name and make full name. Well, that sounds like 3 steps to me, 4 steps to me. If I have a query where I can produce what I want in the first place with the select, I don't need to go and add new columns because select outputs new columns if it needs to. And that's what I've done here. I created a concatenation of first name, quote, space, quote, last name as full name, and I cut out the middleman. Made an easier job for myself. This isn't always going to work for you, but sometimes it will, just like this, in just this manner. I'm going to pause. Questions on exercise number 1 with this full name business? Questions coming up so far? Yeah, Stephen, go ahead. Oh, yeah. Let's see what the describe tells us here. Let's describe employees with departments. It should sort everything out quite automatically. Look at that 31. And it did that dynamically because I concatenated in a space character. If I concatenated in no middle name in the middle, it would expand out the size. Yeah, pretty cool stuff. Yeah, really, really thoughtful question, Stephen. So I would prefer this way myself, if I can. Other times, like with the Z-score stuff, we can't just get that in the select. We've got to make a table, glom on new columns, calculate and derive those columns. Yeah. Groovy. Let's go to Blockbuster Video. That's what the Sakilla database is a knockoff Blockbuster Video database. So,
Brian?
Yeah.
Is on the alter table, when you drop the columns, is there a reason why you listed alter table or alter table twice instead of just listing it on one line?
Yeah, I believe that we can have multiple column drops per drop column, but the paranoid database person in me says I want to do things one thing at a time. So it's an old habit.
Oh, okay, gotcha.
Yeah. Cool. So let's talk about payments. Let's talk about what you owe the syndicate here for renting videos. We have payment ID, customer ID, staff ID, rental amount, and notice what I'm gonna do here in my select, I'm gonna try and make it easier on myself and select the amount, which is the price, the rental price, multiply that by 100 to get the number of pennies. So that's what the exercise is asking us to do. So let's try that out. I create my temporary table from Sequilla payments. And then when I run a select on this, notice we have payment ID, customer ID, staff ID. Those are all lookups to some other table. We have the rental ID that's pointing to what movie you rented, Jurassic Park, whatever. And then I have the amount in pennies. And notice I skipped the middleman of having that amount column and then adding an amount in pennies column, but I'm not out of the woods yet. When I describe my new temporary table here, my amount in pennies is a decimal, which is not what the exercise was asking for. The exercise was asking for an integer, right? So if you take a numeric column, like a float or a decimal, and you turn it into an integer, SQL is going to lop off everything after the decimal place and convert that into an integer. But I'm okay with that because I've already multiplied by 100. So let's modify that amount in pennies. And then when I go back to describe our payments, lo and behold, amount in pennies is now an integer. And a lot of different point of sale systems will have you key in the amount, no decimals. That's one way of getting around some rounding errors that can happen. And now I have amount in pennies as an integer for everything on that temporary table. An order is going to matter here. If you converted the amount column to an integer first, you lose all the 99 cents. That's why I did math first. I did the transformation times 100 first before I manipulated the data type. Right? Oh, okay.
So I guess what's the data?
The not null here, strictly speaking on this exercise, it's not going to matter because we don't have any nulls in this. That's an old habit. I don't try to tolerate nulls if I don't have to. And later on in the course, as you're finding data sets with tons of missing values in them, you'll start getting an itch to not allow nulls if you can. Yeah. I'm looking at that and I can tell you when I wrote this, I didn't think, oh, let me specifically make this not null. It was just autopilot. How we doing on the number 2? Reasonably straightforward? Cool. There's some good learning in there. The good learning of if you change the data type to integer too soon, you drop your pennies. That's going to happen in a lot of programming environments. So just double check your math first before you convert data. And here's another perfect example of using a temporary table rather than altering the original table. I don't run any risk of destroying data on the original table. All right. Let's talk about the big one. Let's talk about our z-score. So let me go and grab the problem statement here. So original problem statement is going to need some chopping down. Find out the current average pay in each department compares to the overall historic average pay. In order to make comparison easier, use a Z-score. We'll talk about a Z-score. In terms of salary, what's the best department to work for? What are your best bets for department? So as I'm looking at this, let's see, current average pay in each department, overall historic average pay, okay. So if I need to get, now we're going to need to calculate averages and standard deviations in order to get some Z-scores later. Check out my little query here. Select average salary and standard deviation of salary from the employee salary table. First step is to make a query that gets me as much of what I can get, as much of what I need. And so the average salary is $63,000. That's an average is one of the ways of measuring what the middle of a data set is. There's a couple of other ways we'll talk through later. And then standard deviation is the amount of spread. How far apart on average are most of the observations from the mean, okay? And these are two numbers, and these are dollars. So I'm not gonna worry so much about the rounding. Now, we could just write those down in the margin of our notes, those two numbers, and use those manually, type them in later. What I'm going to do, though, is make this temporary table that'll serve as a lookup for us in the future. And now, anytime I need historic average salary company-wide or historic standard deviation of salary company-wide, I have that in another table. So I don't have to run that query again. Okay. Questions so far? So far, so good. All right. So I have one nice little temp table holding on to my historic aggregates. Aggregate is a fancy word for a function that you can run on a list of numbers that gives you back one number. Count is an aggregate, average is an aggregate, min, max, standard deviation. They're all functions you run on a list of numbers that give you one number. Now, this next little piece says, okay, I need to check out the current average salaries for each department. Now, if we were to do select average salary from salaries, that gives us one number, right? Gives us one single average salary for everybody. But if we need the average salary for each department, then I'm going to introduce you all to a little language trick. If the problem, or if part of the sequence it takes to solve the problem has a for each, and for each department get the average salary, then you're probably going to be grouping by the thing that you have to do for each. It's a nice little trick. So if we say, give me the average salary of each department, you're going to be grouping by each department. Group by the department name or the department number. It's a nice trick. So what I'm going to do here is say, hey, SQL, give me the department name and the average salary from employees, salaries, from join department employees, join departments, and limit by the 2 dates to have current, and then group by the department name. And I'll show you our results. Before I make the temporary table, I want to get my query and show the results. So looking at what we have department name and each department's current average. So what's going on is on each unique department name, the average function for people who are in that department runs. Notice at this stage, all I've really done is made a temporary table containing the historic average and the historic standard deviation. And the second thing I did was I made a query to get the current department average salaries. Notice I'm not trying to do this all at once. Trying to do things all at once is a recipe for tripping over your own shoes. So break the problem down and build the solution up. and they kind of meet in the middle. So if I'm happy with this query, and I'm pretty happy with this query, in my mind's eye, imagine looking at this query, I'm gonna get the annotation out here. Imagine if we had another column out here called company average salary. And what if we had another column out here that was Z-score? So when I see a query result that I'm going to turn into a temporary table, I'm asking myself in my mind's eye, what else do I want to see there? Because that's going to inform what columns I might add. And it's just an approach, a thought process. So I'm going to create a temporary table out of this here query. I'm going to call it current info, because that's what this is representing, current average salaries by department. And then I'll select star from current info to prove that it worked.
So you have the same wording that data is located, is that just pretty up the best?
Yeah, yeah. I'm not worried about this data truncation because we're yeah, very minuscule. We're talking 100,000ths of a cent, if not more.
I'm sorry, I must have missed this.
No.
As far as you being able to create these temporary tables, they're being created in Ryan, in your personal database, and you already have a copy of the employee's database in there to reference off of, or how do you?
Oh, I'm really glad you're asking. So Ryan Miller asked a great question. Hey, just to confirm, where are your temporary tables going? My temporary tables are going to my database, but you'll notice I'm talking to the employees database with what's called the fully qualified path, which is database name dot table name. And if we had columns in here, we'd do database name dot table dot column name.
Got it.
Yeah. So what do we have on our new temp table? So far I have two temporary tables. One temporary table has our historic aggregates, standard deviation and average for everybody. Now my current info table has current average salary by department. So it's looking like sales is a good department to be in, possibly marketing, but we want to have a little bit deeper of an understanding of if that's really the case. So in my thought process here is get your query as clean and clear and as much as you can get into your query, and then start glomming on adding on new columns as we need them. So I know that I'm going to need the historic average. So I add that historic average. I know I'm going to need that historic standard deviation. So I'm pulling these from that first temporary table once I update them. And I know I'm going to need the Z-score. Why am I making 3 new columns? It's to make my computational work, the arithmetic work, easier. So I can do more without having to have big, long, huge, crazy queries. I can do smaller, tighter queries. And now what we see, each row is a unique department, each department's current average, and then we have columns to hold the historic average of everybody, this historic standard deviation of everybody, and then the Z-score computation. But I'm going to pause real quick. I don't want to move too fast. I don't want to lose anybody. Fred? Yeah, please. Yeah. Mhm. Oh, okay. Okay. It can, yeah. Got it. Yeah, so the Z-score, let's talk math real quick. A Z-score is, our numerator is X minus the mean of X. Of what X is our column of interest here, right? Divided by the standard deviation of X. So what this means in English, would be if we had a table of 1, 2, 3. Let's just build it out. Number, mean of n, well, I'll stick with x here, mean of x, and then standard deviation of x. And let's see. So this is our imaginary table here. We have 1, 2, and 3 as our numbers. The average of 1, 2, and 3 is 2, right? And then so how we get our numerator here would be, I'm going to inject in a little SQL here. Select x minus the average of x.
Can we see what you're typing, Ryan?
Oh, forgive me. I had a screen share that was showing another application. Let's try that again. So let's recap. The formula for a z-score, and what a z-score is in English, z-score is how many standard deviations away from mean a specific observation is, okay? So when I say x here, I'm not talking about one variable. I'm talking about on the first row, x is 1, second row, x is 2, third row, x is 3. And so z is x minus the average of the entire population of x, or the group of x here, and then the standard deviation divided by the standard deviation. So our numerator becomes x minus the average of x. So let's build this out just a little bit further. I'm going to make a column here called numerator. So the numerator would be -1, because 1 minus 2 is -1. Our numerator for the second row is 0. And then our numerator for the third is +1. So Fred's question was about, hey, I was getting standard deviation and by department. Okay.
It seems like it wants to set up one value that column to arrive at standard deviation.
Yep.
But I've got, that's one.
I'm going to encourage you to not break out by department the standard deviation. That's not what we're doing. I know it's tricky and it might be a little confusing, but our standard deviation of x is the standard deviation of the population. Just like the mean of x here is the mean of the population. And instead of x being an individual employee, each row, I know I'm giving you each row is the numbers 1, 2, and 3. But to connect this back to the problem, this would be sales as one, and then marketing as another row. So what we're really comparing here is the department's current average to the historic average of everybody and the standard deviation of everybody. Like everybody.
I got it. I guess I structured it the way
Yeah. We can certainly visit later. Question from Kate. Go ahead, Kate.
Yeah, I guess, I mean, shouldn't we really be using current salaries for the whole company as a comparison? I feel like it's, I mean, I'm fine if that's like the assignment is the question, but I feel like comparing it to a historical salary for the whole company when we're only using current is misleading.
Okay.
Shouldn't we? Okay.
Yeah, for the low price of more columns, we can do both. Right? Does that track?
Yeah, okay. It does.
Yeah. Like I think what Kate's mentioning here, folks, is like the methodology of what we're doing. If we want to compare current by department, we should probably compare current by department to current average of everybody to standard deviation of current everybody. Is that what you're saying? More of a methodology approach?
Yeah.
Cool. I am 100% with you. For the rest of the walkthrough, I'll do it as the exercise is written. But for the low price of adding, because we could answer both questions. We could say historic department averages and compare that to historic average overall population average and historic standard deviation. And we could say current. Because that might inform our analysis. Like maybe historically sales was a great place to work as far as like higher salaries, but currently it's not as competitive as marketing. So we could do both for the low price of simply adding more stuff to our table. And then I could have a column that says current Z-score and a column that says historic Z-score. I would probably, I mean, if we really wanted to dive into that, I'd do both of them. So we could compare not only currents to current, but historic to historic and current to historic as well. Yeah, great point on the methodology, Kate. I like that. Question from Kayla. Go ahead, Kayla.
I think I did both misconceptions. I initially did this. I think I didn't hear exactly what Fred said, but I think I did it initially how he said, and then I did it how Kate said, and then the third way is I'm doing it how you said. And I just don't think it's that big of a deal because in real life, I'll be able to ask clarifying questions to, whoever I'm, getting this information from. But for the purpose of like the quiz or the test that we're going to take, are we going to be able to ask those types of clarifying questions just so that we make sure that we're doing it properly?
Short answer, no. We don't provide help on the quizzes. That's on y'all. We do have a practice quiz so that y'all can practice questions that are of a similar challenge level. Right now, I would say this exercise is the hardest exercise y'all have run into yet, in my opinion. Maybe some of the bonuses on the joins. Your quiz is not going to be this hard. That doesn't mean you're just going to sail through it, but your quiz is not going to be this challenging. And it's open book, open mode. I'm sorry, say again?
Because now we have a few different methods, or maybe it will specify if they want us to use a certain method.
Yeah, the quiz will be some fill in the blank, some multiple choice, some checkbox kind of answers. So it's not this complex, and you don't have to have a perfect, necessarily like the difference between historic and current. I don't think that it's going to be that exacting. Yeah. Kayla, did that speak to your question and your concern there?
Yeah, as long as it's not like this complex, but I definitely had the exact same two misconceptions before I got to this one.
Sure. Yeah, I think this is, at least in my opinion, this is our most challenging exercise so far. So the quiz will be aiming for the middle, not the high end of the most challenging things we can throw at you. All right. Cool. Any other thoughts, questions, comments, concerns before we get into filling out our new column values here? What's coming up? Anything coming up? All right. Now that we have our placeholder columns, let's do something. Let's do something about them. I'm going to update my temporary table called current info and set historic average to be, look at that. I'm selecting average salary from my historic aggregates. So I'm using two temporary tables. They're not free because they cost memory on a server, but temporary tables are basically free. So you use them when you need them. So I'm going to update the historic average. I'm going to update the historic standard deviation, and then I'm going to double check my work. And this is really a good example of getting a single scalar value onto a temporary table, updating that. Okay. Now that I have the current average salary, the historic average, and the standard deviation, what I can do is update the Z-score column to be the Z-score numerator, which is the average or the observation minus the population average. That's our numerator. Then we divide by the standard deviation of everybody. So let's run that one. It ran okay, that's good. And let's select all from current info, order by Z-score descending. And what we see here, Let's zoom in. Sales, so what a z-score is in English is how many standard deviations away from the mean this observation is. So sales looks like a winning place to be. At least in the aggregate. All of this, most of the salaries are going to be higher than the company average. Marketing, wow, marketing is not quite one-to-one. And poor human resources, I mean, that's yikes. Okay, so you can have certainly positive or negative z-scores. So it's nice that these are all positive, meaning that each one of these is greater than the historic average. And we can see that with human resources, 63,009 versus the historic average, 63,008. And if we want to add on department historic by department, historic average salary by department, we can add that on. If we want current average, current standard deviation, we can add that on, get a current z-score, get a historic z-score, and see if they tell us a similar story as well. Yeah, Fred.
What is the scale of the historic standard deviation? Is that just
It is not the difference between those two columns. So the standard deviation is the measure of spread.
Oh, I'm sorry, yeah, that's the average spread.
Right.
That's the total aggregate.
And not quite the same thing as the average spread. It's the standard deviation of spread, but a lot of people will use the terms interchangeably. The nice part about a standard deviation is that it's in exactly the same units as the thing it's measuring. So if we're measuring dollars, the standard deviation is in dollars, whereas like other measures of variance, like variance, would be dollars squared. Yeah, which is less easy to reason about. All right, if this z-score question had you wanting to pull your hair out, don't feel bad. This is pretty challenging. This is pretty challenging. And my walkthrough here, I specifically produced this walkthrough in a way where we built out each component, tiniest piece of component, one line at a time, because trying to do this in one full query would be very challenging. So take heart. We are using all of the pieces that we've been learning and combining them in new ways, right? So we're going to introduce, this afternoon, we're going to get into the case lesson. And that's not the last piece of all of SQL. There's plenty more to SQL, but it's the last piece that we'll introduce. But you can move mountains with these basics, with grouping by, with temp tables, case statements, joins, subqueries. All of these things work together. And the combinations that they can produce can be very, very rich, very, very rich. So I put a couple of links as well if y'all want practice on MySQL above and beyond the curriculum. Folks, I put a number of links in the Jemison channel on Slack. One of them is SQL Zoo and the other is HackerRank. And my encouragement is do a SQL Zoo. I don't know, do a SQL Zoo every day, at least one question, even if we're working in Python. Just keep practicing your chops. We will have more opportunities to practice your SQL in class, but those are going to be part of integrated exercises where you're writing SQL, connecting that to Python, right? So a little bit of steady practice with SQL will set you up right. And I have no idea what the Zoom chat is talking about with rats and models, but it sounds like a video game, so that sounds fun.